Hello. Hi, and I'm going to share my screen. Okay, and in our last class, I will introduce you the 3D world construction and analysis. So before we are talking about the 3D data, and everybody could think about this question. Did you have some problems or the questions when you first met the 3D world, or when you use the 3D data? Did you have some question? You could type on the chat box. And this is 3 questions that is very typically, and it's frequently asked by some people. That is, what is a 3D GIS, and what are the types of the 3D data, and how to display them, and what benefits can 3D data bring in our real life. So, did you guys have the same questions like these 3? And we could take these questions and beginning our class about the 3D data. Okay, so our first question, what is a 3D GIS? The 3D data could describe the landforms like the tall building or the tree or the water surface. Or it could also describe the landmarkers, like that is the venue of the Beijing Olympic Games. It's unlike the 2D data. The 3D data has its elevation value, and the 3D data could display its value. It display its elevation value, and how to start and display the 3D data. Let me take the supermap at desktop as an example. It uses a 3D scene to start and display the 3D data. And what is a 3D scene? The 3D scene uses a visualized technology to simulate various geographic features and their spatial relationships in the real world. And it has 2 tabs, includes the plane scene and the spherical scene. And let me introduce you these 2 types of scene. First is a spherical scene. The spherical scene is more frequently used by the users, and it simulates the surface of the Earth with a sphere. And if you have the data that is a geographic coordinate system and projected coordinate system, you could use a spherical scene. So in our test questions, there have the questions about it. So everybody could pay attention it. The spherical scene supports the geographic coordinate system and the projected coordinate system. So that's our test question. Okay, and then our plane scene. The plane scene is to simulate the spherical surface of the Earth to expand into a plane, and it supports the planar coordinate system data and the projected coordinate system. And so let's open our desktop, and let me introduce you how to create these 2 types of scenes. There have the scenes in our workspace manager, and let's right-click the scenes, and we could create the new spherical scene or the new plane scene by this method. Right-click the scenes and create these 2 scenes. And let's So let me find my PowerPoint. Okay, so that is 3D scene and how to start the 3D data. So, and then what are the types of the 3D GIS and how to display them? So the type of the 3D data can summarize as the terrain, image, vector, KML, and model. So for the terrain data could represent its ups and downs of the Earth's surface. And let's look at the terrain data. Okay. So first, let's open our desktop. Open the desktop and click Open File Workspace. And let's open the workspace of the number 4 folder, the 3D data, and click the 3D scene.snw. Let's find in the data of the first named 3D data, and in the 3D data it have the 3D scene.smw, that is a workspace. Let's open the 3D scene, and I have prepared so many scenes and data source for you. And let's find the Jingjin data source. Let's find the Jingjin data source. Click this drop-down button and find the Jingjin terrain, G-I-N-G-J-I-N terrain. That is the terrain data from the Beijing and the Tianjin and the Hebei province in China. So that is terrain data. And let's add this terrain data to our scene. Right-click this terrain data, right-click this Jingjin terrain, and add to the new spherical scenes. And add it to the new spherical scenes. Okay, and then it will promote as add it as a terrain or add it as the image, right? It will promote as add it as a terrain or add it as an image. So let's double click this box, double click this checkbox and click OK. Let's look at how these two data formats look like. Let's right-click this terrain data and zoom it to the layer to zoom in our data. That is the terrain data from the China, and let's use the middle button of our mouse. And to zoom in and rotation it. It will represent the end duration of our terrain data. Okay, and let's look at our data. We could see its ups and downs of our terrain data, and it will and it also has the color of our terrain data, right? So let's find that let's find the visible button next to our data. So first, let's look at the terrain data is stored in the terrain layers, and the image data is stored in the general layers. So first, let's click this eyes button. Did you guys have some questions? I found it. Okay, and then let's click this eyes. That is a visible button. Let's make the image data invisible. And we could look at the undulation of our terrain, but we can't look the color of our data, right? That also have the question, it test the question on this. So our terrain data could control its undulation of the terrain data. The terrain layer could control its undulation of the terrain data. And let's make it visible and make the terrain data invisible. We could just see the color of our terrain data, and we could not see the undulation of our data. Okay, so pay attention to this. The terrain layers could represent the undulation of our data. Okay, so that's our questions of the test. We could select the terrain data, terrain layers. Okay, and next, let's talking about the vector data. It includes the 2D and the 3D. And so we have accumulated many of the 2D data. And if we completely discard the 2D data, it will be called completely discard. So if the existing 2D data could be converted, extracted, or recognized, it will be rich and recast the data source of the 2D data. So whether the 2D data can be expressed in 3D, the answer is yes. And there have the two ideas. The first is express the 2D layers through the 3D layers. We could use the 3D symbols to express the 2D points, lines, and water. And the second way that for the lines and the polygons, we could stretch our model and set the texture of the model to express it through the 3D layers. And the second idea, if we have the elevation of the 2D data, we could update the 2D data to the 3D data. And if we have the TIN terrain data or oblique photographic model data, we could extract its elevation in the same area. And if we give the elevation to the 2D polygon, and then linearly stretch and map to the generate 3D intensity model. So what's the difference about this method and this stretch method? For the first idea, the stretch and set the text just dynamically to stretch the model. But if we give an elevation to the 2D data, we could generate a real 3D intensity model. So let's do our first exercise of our class. We could, in this exercise, we will use a symbol data source, and we could use the data set of the trees and to generate the unique semantic maps and then render semantic subatoms in turns. Okay, so let's open our desktop and close the window that we not used. And then let's open our scene template. Double click it and open the scene template in the group of the scenes. Double click this scene template. That is our first exercise. And then let's, okay, and that is a community of the area. And for this exercise, we could set the tree to generate it to a semantic map. So everybody could follow me. Everybody should follow me. Let's open the scene template and find the tree dataset in the layer manager, and right-click the tree. Right-click the tree. Right-click the tree and create the semantic map of the tree. Create the semantic map. And let's choose the unique values map and the default. Choose the unique value map and the default. And click OK. Okay, and it will successfully to generate a semantic map. And then let's set its style settings. Move it, and let's set its style settings on the tab of the style settings. Style settings, and then let's modify its altitude mode to the relative to ground. Modify the relative to ground. Modify its altitude mode to relative to ground. In the style settings, in the altitude mode, and change it to the relative to ground. Relative to ground, and set its altitude, change it to 4. We could see the trees in there. Could anybody see it? It's a little point in this grass in there. Okay. And then let's modify the semantic map of the tree. Let's choose the unique expressions to the species of trees. And then let's modify its style. One-click the style of the coniferous forest. One-click it and choose the dot style. First, modify the unique expression. Modify it to the species of tree. And then click the style of the coniferous forest. One-click it, and then choose the dot style. Choose the dot style. Choose the dot style. And it will promote the marker symbol selector. And let's choose the group of the tree. Click this drop-down button and choose the tree. And choose the coniferous forest. Choose this coniferous forest. And modify its scale to 4. It will zoom in our 3D symbol. Okay, let's find in the group of the tree, and to find the coniferous forest, and then modify its scale. Modify its scale. Okay, and then I'm going to click OK. I'm going to click OK. And let's wait a minute, and it appears a 3D symbol point of the tree. Okay, and this is a way to set the 3D symbols. And let's modify it in turns. Click the style. If you're not follow me, you could follow me in this trees. Click the style and click the dot style. Click the dot style and find our 3D symbols in the group of the tree, and click this tree. And that is a tropical tree. And let's find this coconut trees. Click this and modify its scale to 4. It's in order to zoom in this tree, and click the OK. And the tropical tree will disappear in our glass. And then one click this style and click the dot style, and to find the willow. And don't forget to modify its scale and click OK. That is the way to use a 3D symbol to express a 2D point. So did anybody follow me? And that is our first exercise. If you successfully generate these scenes, you could type 1 in our chat box. Okay, that's our first exercise. And did anybody have some questions? Let's check. Can you? Good job, this student. You tapped 1 in our chat box. Mr. Jolie, could you repeat again for loading scene template? Okay, so how to choose a 3D scene? Cello image are 3D by default, right? Yeah, the satellite image are 3D by default. No, that's not default. That is a preparation it by the yesterday, and I did the same. Okay, thank you. So I will do it. I'm going to repeat again for loading the scene template. Okay, it's a really simple operation. We could right-click this scene template, or right-click it and open the scene. And we could open this scene template. Right-click it and open scene. It will open our scene template. And done. Okay, good job. Thanks, I did the same. How to choose 3D scene? How to choose? How to choose a 3D scene? What did you mean? Did you mean you choose Jingjin, or Jingjin is in this data source, Jingjin and Jingjin terrain? And in the node exercise, you could choose the scene template as our exercise data. Okay, so that's our first exercise, and I'm going to take our next exercise to stretch our modeling. Before our stretch our modeling, we could do some data preparation. There have the 5 steps. The first step, we should make or get some building data site. That is a data collection. And the next step, we could get a texture by shooting on the spot or downloading on the internet. And the next step, we should edit our image, just adjust the angle or reduce the pixels in the software like the Photoshop. And then we are going to add the field like their bottom elevation or their stretch height. And then we could edit the data, like enter the field values vertically and save our data. That is our preparation of the data. And then let's look at the operation of the stretch our model. So the first step, we should add the data, and then we could modify the head mode and set its bottom elevation and set the stretch head and set the texture. Some step in details, and I will demonstrate to you for this exercise. For this exercise, I will use the modeling and analysis the data source and use the texture folder in our data, and we could use the data side, the model region layers to achieve the stretching modeling. So for this exercise, I will do the quickly demonstrate, and you could not, maybe you could not follow me, but you could practice after our class. So because the time limited, I will do it quickly. So you could do it after the class. And then let's open our desktop. And don't forget to save our modify, to save our change. We could right click on the scene, right click on our map window and save our scene. Okay, and then we could close our window. And do you want to save the change? We could click yes to save our changes. Okay, and for this exercise, I'm going to use the data set in the modeling and analysis. We could use this modeling and analysis the data set. And then let's right-click the model region. Right-click the model region. Right-click it, add it to the new spherical scene. Right-click the model region and add it to the new spherical scene. And then let's right-click this dataset in the layer manager and zoom it to the layer. Okay, I will repeat it. Right-click the model region and add it to the new spherical scene, and right-click in the layer manager and zoom it to the layer. So, and then let's modify its style settings of the attitude mode. It's just like we have done in the trees. So let's modify it to relative to ground, and then let's modify its attitude. Maybe in your data and not modify its name. If there have the two words, it means the number of the building. It's in Chinese, if it has the two words, it names the number of the building. And for the lift height, we could choose the building height. It has the 5 words in Chinese. Okay, and that is the way to stretching our model, to stretch our modeling. That is the way to stretch our modeling, and we could see that is our building, and it has its attitude and lift head. So you also could set its attitude for another number to try it. And then you could click this texture settings to set its texture. We could set the side texture as a set texture and click its real size. And click its top texture or something else. So you could set it by yourself. And for our scene template, For our scene template, there also have these two buildings or these buildings. And after class, you could try it by yourself to stretch this building. Okay, that is our third, our exercise of the stretch our building. And then next, let's talking about the KML file. So how to display the KML file in the desktop? There have the two ways. Let's open our desktop. Open our desktop. If you're close the scene template, you could reopen it. Open the scene template. And so for the questions, when I finish this exercise, and I will answer you. Okay, and so now you guys should follow me. Open the scene template. Open the scene template. We could right-click it and open the scene. And then let's find in the tab of the scenes. In the tab of the scenes and in the group of the data, there have the KML file button. And we could click this button to load our KML file. Click this KML file and click the load KML. In our data folder, there have the 2015 Beijing subway.kmz. You could choose this, the metro of the Beijing. Click this to load the KML file. And then let's right-click this KML file and zoom it to the layers. That is the metro point, the point of the subway of the Beijing. That's one method to add the KML file. And there have the second method to right-click the general layers on the layer manager. Right-click the general layers, and it has the button about the add KML layers. There have the button about add the KML layers. Okay, that's two ways to add the KML file. And let's look at, did you guys have the questions? What does KML stand for? KML stands for the file, the data format named KML. And it's a type of file or, okay. On the question. Okay. 3D use. Okay. I have seen this. I managed to load scene, but could not edit ground control. Okay, you could use the software like the Revit or the Bentley, and you could use the plugin and export your data, and to import the supermap at desktop. Okay, you could use the software that is to make your modeling, like the Revit or the Bentley, and you could use the plugin to export it. And for this part, I will introduce you for the next session. Thank you. Okay, thank you. And let's go to the next tab of the model. Okay, and then I'm going to introduce you the model data set. I will take the BIM and Oblique Photogrammetry as an example to introduce you the model data. And so first, let me introduce you the BAM model. For the BAM model, we could make the BAM model on this software like the Revit, Bentley, and so on. When we finished make our BAM model, and we could export this model and to our supermap at desktop to a 3D and 10T model, and to do some analysis like the query or so on. So there have the two methods to export it and import to the supermap at desktop. The first method is to directly import the BAM model. And the second is to use the plugin to export your model and import it as a format, use the format conversion tool. So let's look at the first method to directly import it. It's simply demonstrate, and if you have the BAM model, you could try it. And let's choose the data source. Choose the BAM data source. Right-click it and choose the BAM data source. And there have the button to import the BAM data. And it supports the 3D XML or Revit or CTGML and so on. So we could use this method to import our BAM data directly. Okay, that's our first method to import the BAM model. And our second method to use the plugin to export, there have the video. Okay, and let's look at this video. That is use the Revit to export our data. So for another software like the Bentley and or so on, or for the another data format like the 3ds Max, 3ds Max format, or something else modeling, you could use this plugin to export. So if you know, if you see this video and know how to use plugin, and you could export every model like the BAM or 3ds Max, or you use another software. So let's look at this video. That is a Revit, and we could click this 3D views, click the 3D views, and then let's find the add-ins, and there have the plugins named the Supermap Export, and click it, it will promote windows that includes the parameter setting. And we could set the insert point. That insert point is the original point of the Revit or the Bentley or the another software, and we could set it a spherical coordinate system or the planar coordinate system. And we could also customize its projections, and we could start it in the new data source or in the existing data source. So that means we could export this data as our data source, and it could directly add to our supermap at desktop. And then we could also set its color tab or some another parameters about the improve the efficiency. And then and then we are going to click And if we have finished set its parameters, we could click this OK and wait for a minute. It will prompt us that it's export successfully. And then we could open the super map at desktop and click and open our data source that we have stored our BIM data, and click its data source and open its data source to our map window. Add it to the new spherical scene and zoom it to the layer. Zoom it to the layer and to look at that is a BM model that we have done on the Revit software. And we could also to look at its attribute table. We could click one component and to see that its attribute, like its tab or the level or the area, something else or some on. So that is a way to use the plugin to export the BIM data. So let me look at if any people. 快一点 ，OK. And then let's look at the next Oblique Photogrammetry Toolbox. Okay, that is a way to import the Oblique Photogrammetry dataset. And that is a toolbox in the Supermap at desktop. And I will introduce you for it. Click the 3D data, and there have the group of the Oblique photograph. And there have the button of the data management to import the Oblique photogrammetry data. And there also have the button to process the Oblique photogrammetry data. And then let's click the data management, click this button, and click the generate the configuration file to import the Oblique photogrammetry data. Click this, generate the OSGB config file. So everybody could follow me for this step, and we could choose our data in the the first folder, the number 4, the 3D data, and find the OSGB cell in the France. That is district in the France cell, and let's click this tile 008006. Click this folder. In the number 4 folder, and find in the OSGB cell, and find the tile 008006 and click OK. And then let's choose the result settings, choose the target path, and we could choose the OSGB cell. Choose this OSGB cell. Click OK, and to modify your name, we could name it as a test. We could as a test, and you could also modify its projection, set its projection, or set its coordinate system translator settings. So in this exercise, we could not set it. So let's directly click OK. It will promote as it's recommended that process the texture, and let's click OK to generate the SCP file that includes the OSGB file. And then let's add our OSGB file on the scene. So let's right-click the scenes, and click the new spherical scene. Click the new spherical scene, and right-click the general layers, and add the OSGB cat layer. Click this, add OSGB cat layer, and find that the configuration file that we have generated. Find the test file, click the test, and right-click the test and zoom it to a layer. So because of I have not set it a projection, so it's in the C. So you could set your own data's projection. Okay, and that is OSGB file. How to import the OSGB file and display it in the 3D scene. Okay, and that is about the Oblique photogrammetry file, and that is a step of how to generate the configuration file. So that is so many types of the file, and I have introduced you so many types of file. And if you want to improve its effects, and the SuperMap at desktop provides a 3D catching strategy to improve its efficiency of the data. Okay, and that is a step to generate the scene catch. And let's look at how to generate the scene catch. Can you repeat this part? Okay, because of the time limit, so I will tap our step on the WeChat group. So if you have not come in the WeChat group, you could come in now. Okay, and then let's go into the next step to look at the create the scene catch. Let's use the CBD scene as the example. Right-click the CBD scene, right-click it, and create a scene catch. Create the scene catch. So it's prompted us to close it, and let's don't close it. Okay, and don't save it. And open the window that we could not use. Okay, and it will promote us a window. It is a generate scene catch. And then let's select the all data site. Select the all data site, and to modify its parameters. And we could modify the storage tab or the file tab. Okay, so because the time limited, and I will not generate the 3D scene, and you could directly click this generate and to generate a 3D scene. So I have generated a 3D scene in this CBD folder. That is the result that we generate a scene catch. It includes so many folders, and includes so many data sites. We could click these folders, and it will generate the .s3mb data format, and it will have the .scp configured generation, and it also has the workspace, and its extension name is .sxw. So let's add this 3D scene, and let's right-click the scene and create the new spherical scene. Create the new spherical scene, and right-click the generate and add the OSGB catch layer, and let's choose the CBD, choose .scp file in terms of the CBD scene. So first, let's choose the building, and then choose the ground, and then let's choose the ground 2, and then choose the tree, and then choose the waters, and right click it and zoom it to the layer. Okay, and that is the catch of the CBD scene. That is how to import the efficiency of the CBD of the 3D data. And then let me introduce you the last questions. What the benefits can 3D data bring in our real life? So let's do the exercise to feel its benefits. That is a situation that if you come to Beijing for the first time and you have found the restaurant on the 79th floor of the China World Trade Center and you want to see the view of the Beijing CBD, the Central Business District. So first you want to know if you can see the pavilion of the park, and then you want to know what areas you can see and what areas you cannot see. And then you want to know what times to go to enjoy the sun. So we could do this 3 analysis to look at to do this exercise. So let me introduce you in terms. And the first is the visibility analysis. It is to determine whether the central locations in the 3D scene and are visible to the observed location. So if you want to observe the pavilion, if you want to determine you could whether you could look at the pavilion, you could use this visibility analysis. And the view shed analysis, that is to identify all the visible and invisible ranges in the analysis area of the scene. And then it's the trajectory. The trajectory button is used to set the trajectory of the sun effects. So let's do this 3 analysis as soon as possible, and let's find the 3D analysis on the tab. Find the tab of the 3D analysis, and there have so many functions of the 3D analysis. And so first, let's find the visibility analysis. We could draw observation. So that is the central building, and we could find your restaurant. Maybe it's in there. There is your restaurant, and you could you want to know if can look at the pavilion. So you could click the pavilion. Yes, the green color, it means you could look this pavilion. And let's look at another area if you want to this building. And the red color of the line, it means you could not see this building. Okay, or you could click whatever you want that you could see. So that is a question of our test. If you want to the pavilion, if you want to know whether you could see the pavilion, you could use this visibility analysis. And then it's a view shed analysis. Let's click the observation area, observe location, and to look at the green area is you could, if the visible area, and the red area is the area that you could not see. So that is watershed analysis. And the trajectory is in the scenes. In the top of the scenes, there has the trajectory button, and there have the button, and we could drag this button to look like how to look at what's the sunlight. Okay, so if you want to go there at 12 o'clock, and you could see that is good view of you could enjoy the sun. So that is the benefit of our 3D data. And so, and finished my class. And so thank you. Our last class is finished. Okay.